grade 7 students, and welcome to the second last of the sessions that we'll be holding in the coding robotics classes. I want to welcome you to this midday class, and I'm grateful and thankful that you are sharing in the experience this week. I hope up to now you have learned something interesting. I know yesterday's lesson with the introduction of variables was a bit challenging. And I know that if you spend a little bit more time with the code, you'll eventually pick up what is going on. You just got to experiment a little bit. But I decided today that I'll do something interesting with you that perhaps is maybe not as complex as variables. And I want to link in how to use a variable with what I'm doing today towards the end. So you'll get another chance to see a variable in use. But welcome again. I'm your facilitator, Mr. A.F. Gabriel. This program is brought to you by Africa Teen Geeks. And don't forget that the competition is happening. And this weekend, hopefully you will work on some MS Zora block code and submit something. Even if it's really small, even if it's very little. Remember, you've only been working for 1 week now, so we don't expect you to be a genius programmer. So don't think that your program is going to be silly and it's not going to win. Just submit, and you never know. You just might be the winner. Okay, so just before I take you to Masora, I just want to show you the slide here. And okay, my PC is misbehaving again, and it's not switching the slide. But yeah, while we're just waiting for that slide to show up, now here we go. Now this slide, I just put this in there because at least now it's permanent. When you download the recording of this video, you'll be able to get to this slide. If you forget what numbers on the axis X and Y are used to turn the direction of the sprite, you see, it doesn't measure like your protractor. So that's where things get a bit crazy, right? So if you want the sprite to turn right, you say 90 degrees. If you want the sprite to face north, your turn angle is 0 degrees, or you say direction 0. This direction here, that's the tricky one. It is negative 90 or minus 90 degrees. And if you want the sprite to go down, then you're going to go 180 degrees. Okay, so just remember these things, and you'll see that's the direction that we use to actually turn the sprite. Now, if we can just quickly go to Ms. Zora, let me just open the browser. I had this all open and ready for us to use. Let me just get that out the way. Right, here we are. You can see I'm on the blank program. And I just want to show you that direction. I want to show you that direction and the best. In fact, that's the reason why I put the arrow on yesterday, but we never get a chance to actually see that. Okay, so you've got an arrow on the screen, right? And if we go to our motion and we say point in direction 90 degrees, and you run this code, and if you remember the slide, 90 degrees was exactly in the direction that it's facing. You'll see that when we run this code, let's just put an event there. When the flag is clicked and you press the play button, you'll see that it's pointing to the right. Now let's put 0 degrees, right? And you will see that when you run the code, it will point upwards, because now you've changed the direction of the sprite to face upwards. That's what we did with our sprite when we were drawing shapes, and we changed or turned the sprite's direction. Also, you'll notice there is a little clock there that kind of helps you to see where you are. Can you see now minus 90, and this little clock system is showing that it's going to go to the left, and you'll see the sprite is now at the left position. And lastly, look what happens when you type 180 and we run the program, and now the arrow is pointing down. If you make copies of this instruction, let's go duplicate. I got 2, duplicate. I got 3, duplicate. I got 4. and let's join them all up together, right? And then let's start from 0. And then for the second one, we will go, sorry, not 0. Let's start with 90. And for the second one, we'll go 0, which is up. So we wanted to go from the right to up. And then for the next one, we will go minus 90, which is to the left. And then for the fourth one, we will go, well, 180 is fine. So can you see 190, which is your left, 0, which is your up, minus 90, which is your left, that way is right, and 180 degrees is down. And of course, that's going to move very fast. So we are quite familiar with this wait 1 second, where we'll create a delay. But I think 1 second may be a little too slow. So let's make it 0.5. Right now, kids, let's talk about decimal numbers. I know in school you would have learned about decimal numbers. And I know we had wait 1 second there, but we could actually change that to a decimal number. We can't have a fraction here. I know you know that 0.5 is half, but we can't actually quite type half into our instruction. So we have to use a decimal number. And so you use that with the comma. And I think we know that 0.5 is half. So that's like half a second. But again, even if you don't know, how long 0.5 is going to be, you can actually just fiddle around with the decimal numbers, put 0.2 next time when you run the program and see what happens. Now, I want 4 of these, so I'm going to duplicate. Actually, I don't need 4, I need 3. So we'll put 1 after that one. We'll put 1 there, and we'll put 1 there. So can you see we're changing the arrow's direction, and then we are making a little delay. We're making the computer wait half a second before it changes the direction again. And let's run this program. Can you see? Let's run it again. And now you can see all the 4 different sides that the arrow is facing. I think you like that one there. Okay, now kiddies. Oops, that was a mistake. My apologies, I think we're all back. I meant to click on the chat and I clicked on the wrong thing. Sorry for that, everybody, but we are back in. Okay, so now I have a question for you guys, and I want you to answer this question by using the chat. How do you think we could make this arrow turn around and around continuously, and so that we don't have to rewrite the code? We want to make it go around a second time and maybe a third time and maybe a fourth time. I taught you how to do this using one of the control structures. I also put the control blocks on the screen. And can you see one that you think we could use? Right, Nur Mohammed is talking again, and Muletsi, you're talking again. Use the repeat block. Use the repeat function, right? Okay, so let's pick the repeat that we used yesterday. Here's it, pretty cool. And well done, thank you. You guys are pretty good. Nice to have you responding and talking to me. Okay, so let's put this repeat block into the window. Can you see as I hooked it in, can you see the shadow is surrounding all my blocks? And look at that, we've got this entire arrow surrounded now. And the repeat button is saying repeat 10 times. So let's, and Noor also said, and type in how much you wanted to repeat. That's good, yeah. So 10 times. Okay, and now it's just going round and round and round. Okay, it's jumping from the left to the right pretty fast because of the, we need one more wait delay after this one here. So let's add one more, wait 5 seconds. We don't need that one, I'll chuck that out. Let's put one more wait 5 seconds there, right? And I'm going to do something interesting. You saw it happen there. I'm going to take this entire block of code. Again, as I'm watching, I hope you're watching me as I separate code so you can see how you can pull, just like Lego, you can pull bits and pieces out in big chunks that you don't want to use or move things around. Now I'm going to switch out. I'm going to take the repeat loop out, and I'm going to use this one. Check this one out, guys. It says, it doesn't say repeat. It just says forever. Ooh, what happens now? Well, let's put this in and actually see what happens now, right? And click that. I'm sure you know, you can guess, right? And click the play button. And this arrow is pointing in each direction, right? Top, left, down, top, left, down, right, top, left, down, right. And that's the rhythm. And guess when it's going to stop? It ain't never going to stop, because that's how a forever loop works. This loop is just going to keep going forever. The program will not stop at all. There are some, like I said, in normal things, you might not want to use such a thing. But in gaming, for example, if you've got an enemy ship that's shooting, you want that ship to continuously shoot. It mustn't stop. You don't know how long the user is going to play or shoot against that ship. So you can actually design a sprite that just continues to shoot out until, of course, it's killed. And then lucky we've got the stop button there, so we can stop running our code. So I think I used it once or twice before. But yes, if you forgot, that's what this red stop next to the flag is. At any time, you can press it to stop running any of the code. And that's 0.25 seconds. And here is how it looks like animation. And in a sense, it is. So you can see how we just simply changed the direction of something, and it looks like we've animated it, like we've made it move. I just want to make it move faster. You can see, let's press the stop button there. Okay, so we're going to go 0.2 seconds this time. And I'm just teaching you how you can control the animation, right? How you can control the animation. In terms of how fast or slow you want something to go. Now I dropped it from 0.5 seconds to 0.2 seconds, and now you can see that the arrow is changing direction a lot faster. So, and it kind of looks like an animated flashing arrow, but there's nothing animated. In fact, if you look at our code, there isn't even a move button in there. Yeah, so we're not even moving anything. We are simply changing the direction of the arrow. But because of its speed and how fast it's doing that, we have sort of created the illusion of movement. Okay. Anyway, part of what I wanted to show you, let's stop that code, was firstly so you can just learn the direction. When you want your sprite to face any particular direction, those are the numbers there. It's not like in sequence. In fact, we might not even, we want to ask, well, why is those funny numbers? We don't even know. So 90 points to the right, 0 points up, minus 90 left, and 180 degrees will point down to the bottom. Okay, and that's our arrow. Now, I want to show you the repeat loop in connection with another technique of animation, right? You can change the direction of something and it could look like it's animated. Remember, the word animation simply means to create movement, to animate as otherwise lifeless or still object, is to make it appear. It's actually not moving. It's really clever artificial intelligence, clever computer programmers behind the whole thing. But we call it animation, right? So let's pick another sprite, and I think, oh, there's so many sprites that we can animate. But I like the, oh, there's the dragon. Right, let's take this dragon. Now you can see that if you looked at his pictures, he is a fire-breathing dragon. You like this guy, guys? What do you think? It looks like a Pokemon. Okay, but I want to take you now to an area which we didn't look at in the course yet. I took you to the sound area, but well, there's also the costume area. So we're going to click on costumes. And costumes are the three ways that this sprite actually appears. Now you can see that the costumes are labeled. Now look to the left of the screen. You'll see that this sprite has three costumes. A costume is just a word that MS Zora uses for how a sprite appears on the stage. So costume 1 is called Dragon A, and the costume is just standing in this upright position. Costume B is and what's happening now is that the dragon is kind of has its front paws picked up, and the back legs have swung towards the left to create the illusion that it is like, jumping forward. Then it is settling down again, but this time in the third costume, it's breathing out some fire. Ooh, look at that. A nice flame coming out of the mouth there. So those are the three costumes. Now they are actual pictures. Look at it carefully. I'm going to go through each one. That's the first one. That's the second one. And that's the third one. Now they are separate pictures, but they are showing the dragon in different positions. And in actual fact, that's exactly how animators work. If you watch Disney cartoons or anything of that sort, you will know that they draw each of those things and then play the drawings back or flick the pictures so fast across the screen that your eye is tricked into believing that it's moving because the pictures are flicking past you very, very fast. So that is the same trick we want to use here with these three costumes. We want to switch the costumes of the dragon in such a way that we can make it appear that it is moving. Okay, so let's go back to our dragon code. So this code is for the dragon. Ready to begin, guys? Let's first, as always, pick when the flag is kicked. We want to start the dragon moving when the flag runs. And the costumes are found in looks, right? So it's the appearance of the dragon, right? So we can say switch costume to dragon, and we want to start the dragon in position A, which is the normal standing position. Okay, now you can see a little button there called next costume. We can particularly choose the next costume, especially if the order is not right for us, or we could use the next costume button. But let's switch the costume 3 times. So let's pick 3 of these because we want to switch them. And of course, we're going to need a delay in between because otherwise it will switch so fast that we won't see it. We need to pause enough time for the eye to be able to see the movement. So that's switch, wait 1 second, switch, wait 1 second, switch again, and let's wait another second. Okay, welcome, George. You must have some really good stuff, but hope you can catch up. Don't forget, you can check out the video. Right, so we want to switch from dragon costume A, which is there. It's saying C there, but we want B to go first, and then we want C. So can you see our costumes? It says costume, switch to costume dragon A, switch to costume B, switch to costume C, wait 1 second. Let's put our flag button in there so we're good to go. And we say, let's press play. So, did you see that? Okay. I also have code for this arrow, which is moving because it also starts when the arrow is clicked. I don't want the arrow to move, so let's separate him from the when the flag is clicked. So the arrow, can you see I separated it now? So the arrow won't move when the flag is clicked. Okay, so did you see that? Let's actually select the sprite now and let's try that again. So second, third, and he's breathing fire. And well, he stays with the fire. We can switch him back to A at the end if we want him to stop breathing fire. Okay, look at those three the 3 costume switches. Can you see how we created animation through just switching costumes? And it's a pretty slow movement because it's 1 second. So let's suppose we change the delay to 0.5 seconds, and then it might look like a much more smoother movement. And that's really what you got to do here, guys. You got to just experiment with the delays in order for us to be able to control the kind of animation that we really want to make work. So watch that now. That's a little bit faster. Now that's a single movement. The dragon is switching between 2 costumes just once each time. If we wanted to continue doing this breathing or breathing fire, we can, of course, pop in a repeat loop. Let's pop in the forever one that we did already with the forever loop before on the arrow, and let's put it around all our code here. Can you see it's ready to grab everything? And now this dragon is continuously going to breathe fire as we press the play button. So let's have a go. Okay, and of course it's going to continue doing this, and that's a delay of 0.5 seconds. Let's stop that and change the delay to 0.2 seconds. 0.2 seconds. Now I want you to see what I'm doing, right? I'm going 0.2. I'm going to change it there, and I'm going to change it in 3 places. So, and if this dragon had 4, and there are sprites that have lots of costumes, there's some sprites with 5 or 6 costumes. So if you're experimenting with the delays and switching costumes, you're going to be changing the delays every time in about 5 buttons. I'm going to show you how we're going to solve that problem just now. But let's just test 0.2 delay. Look at that. He's moving much faster now. Ooh, look at that. Burn me down, boy. Okay, so, and he's doing that forever. Okay, so now we're going to introduce a variable like I did yesterday. I did say I'm going to teach you a little bit of animation, but then we're going to combine it with the use of a variable. Now let's go to variables and let's make a variable. Let's remember the procedure. Let me cross that off so I show you again. So you select this, the red blocks, operators, dark red, slightly lighter red for variables, and you select the option that says make a variable. We'll always do that when we want a variable, right? Now this variable is going to control the delay, but we don't say delay. I mean, suppose you can, but I'm going to use the word speed because this delay or changing the weight there actually causes or adjusts the speed at which the dragon does its fire breathing thing. So let's call it speed, right? And then we will choose this first block, which says set the variable to an initial value, right? And so we will change, not my variable. Now there's our variable that we made. It's called speed. And I'm going to say set speed to 0.2. And that sets the time for the variable, the delay straight away. And then instead of putting 0.2 there, I'm going to put our variable speed there, wait speed seconds. And then this reads wait speed seconds. So whatever speed is, that's how many seconds this wait delay would take. Now I set speed at the start to 0.2. So the delay at the moment is still going to be 0.2. Let's press play. And of course you can see in the window, the speed is displayed there. So you can see it starts at 0, but when we run the program, you will see that speed is now 0.2 because it's set here. That's what this red set statement does. And our fire-breathing dragon is now speeding and delaying the costume change at 0.2 seconds. And that's your animation. Now let's see why that variable is so useful. Let's suppose we want to test and make it go even faster. Before I had to go here, change, change, change. Now I'm not going to do that. I'm going to go to the set speed variable button, and I'm going to change the speed to 0.1. So that's like a little bit faster than 0.2, and then go, look at that. Ooh, he's moving really fast now. And of course, the faster you go, the less animated the dragon would actually look. Again, it'll flick so fast through the images that it's just too fast for the eye, and we really don't see anything that looks like animation. So you've got to find the perfect delay, and I think like 0.1, 0.2 looks pretty okay. Let's go just smaller than 0.1, and that would be to put a 0.05 there, another 0 in front of it. That's a really small delay, which means it's a very quick movement, and you can see it's really flicking between those movements, and the animation is not so smooth. It's not so, because we can just see a little bit blurry images there. So can you see, as the programmer, you have got to work out exactly what it is you want and how you expect it to look, and create the perfect animation. And again, you can test. I mean, as you can see, I experimented. We started with 1 second, then we went to 0.5, sorry, then we went to 0.5 half, then we went to 0.2, then to 0.1, then we went smaller, decided that was too fast, and now we've come back to 0.2, and I kind of like this speed. It's a nice speed to see the dragon kind of moving and breathing fire. And that, of course, now, if you look very carefully, you'll see we've combined the use of a variable and, of course, the the dragon switching its costume and appearing as if it was breathing out some fire. Pretty cool animation. Okay, at this point in time, I am going to pause here and I'm going to give you the opportunity to ask me anything so far before we move to the next stage. Is there anything you would like to ask me before we move to the next phase? And we're still going to work with the dragon. We're still going to do one more interesting thing. Talked about it yesterday, but I don't want to get you all confused and lost. So if you need me to explain anything in the code that you are looking at right now, I'm very happy to answer any questions you might have. Are we all good? Okay. Yes, it looks like everyone's happy and there are no questions. So I'm going to move on to the next stage now. This dragon is breathing fire. So let's get the user involved. Okay, I'm going to introduce you to an area of a program which we call input. Okay, input is the technique of when we ask the user questions and we actually record responses from the user, or in other words, we can actually get an answer from the user and store the answer, and then of course use it. Now, to demonstrate input, you can see that our dragon is moving forever, right? So I'm going to take the forever section out of this, right? Here it is there. In fact, let's check it out. And here's our dragon just switching costumes one time. But this time we're going to ask the user, we're going to say to the user, how many times would you like the dragon to breathe fire? And if he says 3 times, then we want the dragon to breathe 3 times. If the user says 5 times, then we will let the user choose how many times he wants the dragon to do that, right? And so we're going to need a variable for that, right? We're going to need a variable. Let's make a variable. This variable will be how many times the dragon has to breathe fire. So I'm thinking for a good name. Let's call it like we don't want to call it how many times now. Let's call it okay, let's call it fire for how many times we want to see him breathing fire. We'll say fire for the fire breathing dragon, and he must fire so far 0 times. Now we want to ask the user that. We want to ask the person using the program, how many times would you like to see this dragon breathing fire? Okay. Now, new things, and if you got your notes out there, I'm going to teach you a new thing today that we didn't use this week at all, right? Whenever you want to do this, whenever you want input, now input means the user must enter things. We have to go to the sensing, okay? And you will see a button there called ask. Can you read this? It says, ask, what's your name? That's a standard one. We can change that, right? So we select this. Okay, now let me take them both out. And we also need the user's answer. Okay, so these 2 buttons, which are found in the sensing, and this has gone from orange, from like, dark orange to like light orange to mustard or yellowish, whatever you want to call it, right? So this is the sensing section. Sensing means that the computer or the robot we are controlling must now stop and sense and wait for the user to give instructions. Okay, so these 2, what I want, and this is the only one I'm going to teach you from there. There are lots of other things, and you can, again, when you have time, you can experiment with all these things, fiddle around and write code. Just chuck them in and press play and see what they do. That's the best way to learn. But today, we are simply going to use the ask and the answer. That works together, right? And it says ask and wait. Now the question we can ask, you can see it's the white space, so we can change it. We're not going to ask the user what's his name, right? Here's our question. I go in there and I say ask how, oops, I can't spell, I put home, how many times must I fire? So the dragon's asking that question. How many times must I fire? Right, that's the question. And of course, the answer gets stored in this little button here called answer, right? So what do we want to do? We want to put the answer into our variable called fire. So we go to our variable section and we select set, and it says set fire to answer. Now watch how this works. We ask the user a question, and the answer that he gives us gets stored in the variable called fire. That's what it happens. So where is this variable? It's saying 0 now, but this variable is coming from the user, the person watching the program. Now let's give this a little test run, and I'm going to make the stage full now so we can see what that does. I'm only looking at that piece that's there, right? And let's press play. Okay, now look at the bottom there. It says the dragon is saying, how many times must I fire? Because we had that ask section there. Now I want you to look at the bottom of the screen, and at the bottom of the screen you'll find a little space with a little blue tick on the right hand side. In the space, if you click in it, you will then see that it gets highlighted in blue, and there's a little flashing cursor there which allows us, or in this case whoever is watching the program, they are going to be able to type in an answer there. Let's say he says 3. When the user is done with 3, he needs to press the tick. Okay, so done. Now your input is complete. You have completed the input. Okay, nothing happened. It didn't breathe 3 times because we didn't write anything. Can you see the code was separated? I just wanted to show you how this ask works. So this is very much like, it's just like I taught you this one yesterday, say. It's the same thing, but except say just talks, and ask is asking a question, and the question is waiting for an answer. And the computer keeps the answer, and we take the answer and we are putting into one of our own variables, fire, because we want to use that variable. So that's how it works. Now let's go to a control structure, and let's pick, and not the forever loop. That's why I took the forever loop out. I want the repeat loop, and we're going to make this dragon repeat its fire breathing technique. The repeat loop has 10 in it, and now I'm going to ask you on the chat. We are not going to put 10. Who knows what we're going to put there? What shall we put in the repeat loop so that we can control how many times the dragon is going to breathe fire, because the user of the program has chosen a number? Okay, answer. You can answer in the chat if you'd like to say. Okay, Mulesi says answer. Very good. We could put answer there. We could, but remember we made it. Answer would work because answer stores the how many times it's fired. But we actually also put it in one of our variables. Which variable did we put it in? We put it in our variable called fire. Right, very good. We put the yellow thing, the yellow block that asks the user how many times. That gets stored in answer. And look what we did here. Okay, now everybody focus on this line where my pointer is. Set fire to answer. Fire is our variable, right? Let's go to variables. Here's we made 2 variables in this program. Speed, which controls how fast the dragon changes costume, and fire, which is how many times it must breathe fire. That's our variable. So what we're going to do is we're going to put fire there. Right? Fire is just a name. We made the name. It's not called fire because the dragon breathes fire. It's called fire because we named it that. And now the dragon will breathe as many times as the user asks. Let's test run the program now and see what happens. Let's maximize and let's press play. how many times must I fire? The dragon is asking because we've got an ask thing there. So let's say 3 for now. And then we press the tick. 1, 2, 3. And she stopped. Look at that. It went exactly as many times as we chose. Who's in control? The user now. And he looks like, oh, look, I told the dragon to breathe 3 times, and he breathed three times. Also, can you see it ends with that fire in the mouth? And that's kind of like, maybe that's a little bit untidy, right? Because its last costume is C, which is the fire. So when all is done, maybe what we want to do is we want to switch the costume back to A, which makes him still. And let's see how that works. Now, look at our code. We set the speed to 0.2. We ask the user, how many times must I fire? He tells us. We store that in our variable called fire, and we say to the repeat loop, fire this many times. And it'll go and repeat and change the costume that many times. Let's see how it runs now. And this time it says, how many times must I fire? Let's say 5. The last time I did 3. And we press the tick. 1, 2, 3, 4. And of course, we didn't see the last one because it was too fast. Look at that. Fire is now 5. And the dragon is also stopped in a position which was, well, without the flame. It's back to the position that she started in. Let's do it one more time. And let's slow the speed down. Okay, leave the speed. Let's just try, let's say 9. Let's go 9 times and go. There you go. Did you count that? 9 times the dragon fired and then stopped. So can you see now the user feels pretty cool. Hey, look, I told the dragon to fire 9 times in this case. And yeah, it fired exactly that many times. So now you have a variable there, and you've also you interacting with the user, and now you can do things with the user as well. You can ask questions. Do you know that we can also get the user to control the speed? Let's do that. Okay, we go to sensing. Okay, guys, you want to help me out? What do I need from the sensing? Because I want to ask the user about how fast he wants the dragon to go. The same thing I used. I was hoping you'll say, like, it's called the ask and wait. Okay, very good. Let's say ask, right? And we will say please set my speed, right? And we're going to have to set the speed now, not to 0.2. We set it to 0.2, but again, we will set the speed to whatever answer the user gets us. Now, can you see why we need our own variable? Because this answer is always what the user gives us. So there's only one. If we need to ask the user 2 questions, we need to store those answers in 2 different places. So we need 2 different variables. So can you see our 2 variables now, how cool they are being used? We've got one that's controlling the speed of the dragon, and that variable is called speed. The other one is controlling how many times it fires. We first tested it with our own variables, and then we decided let's ask the user to do that, right? The user might not know, if he gives us 5, then the dragon's going to go, the delay is going to be 5 seconds. And this says, please set my speed, right? So the user must know he should put things like decimal numbers, but we can tell him. I'll show you how we can do that now. And let's put tick. Now that was the first ask, right? Now it's gone to the second one where it's saying, how many times must I fire? That's the second question, because we've got two ask and wait. Now we say, okay, let's just say 6, and let's just click on the tick, and now its speed is different. It's 0.3, and it's fired 6 times, and the user is doing everything. Let's set a very fast speed, 0.1 this time, and let's go 9 coughs, 9 times breathing fire. And you can see 0.1 was pretty fast, and he's gone 9 times, right? So input is very, very interesting, because you can see now the user is more excited to interact and work with your program, simply because he has a chance to actually interact, work with it, and do things with the program. So he feels he's a part of it, and he has the control of what's going on. Okay, now, yeah, that's the thing. Okay, I wanted to also say to you, please select my speed, and I'm thinking maybe we can give him a little bit of information. Choose a decimal number between 0 and 1. Let's move that to the left. Now you can see how things can get long and why you might need this. So you can see a lot more of your code. Okay, and now let's go there and let's run our code. And the Dragon says, please set my speed, choose a decimal number between 0 and 1. Okay, and every self-respecting mathematician would know what anything between 0 and 1 means. And you can pick anything. But can you see that instruction there? Choose a decimal number between 0 and 1. That tells the user exactly what he's supposed to do. Initially we just said, please set my speed. So the user's looking at the question and saying, please set my speed. Now what is that? What do I do? What can I choose? He can see the number flashing at the cursor flashing at the bottom, but he has no idea what speed is and what it's supposed to do. But when we say, please set my speed, choose a decimal number between 0 and 1, we are giving him a very, very clear instruction, and the user now knows exactly what is expected of him and what he's supposed to do. If the user doesn't know how to pick a number between 0 and 1, then we will say that he is too small to be using our program, because he doesn't know what decimal numbers are. But as you can see, this is what we call being user-friendly. I mentioned that to you yesterday. And it's very important to be user-friendly, because this makes sense to the user. Users get very fed up if a program is asking questions and they don't even know what they are supposed to do. Okay, I'm going to save this to the cloud, and I can't get access there. Okay, so I'm going to call it Dragon Fire, and I'm going to say save to cloud. Ticked. So that program is saved. And again, I'm going to pause at this point to see if you want to ask me any questions. Is there anything you want to ask me so far before I go to the last phase of the class today? We did some cool animation with switching costumes. I think you can see how you can pick a lot of other sprites and muck around with them, right? So are we all okay there with this stuff? We all happy? Let me click the middle phase again. Okay, let's stop. The program is running now, so let's put a stop to that. Okay, I'm going to take you into the sprites. And now, if you put the mouse, when you go into the sprites and you hover the mouse, there's one really nice one that has 4 movements. She's called I think she's there's the ballerina. I like that. Look at that. She does this little jump in the air. She's got 4 costumes, 1, 2, 3, 4 to switch. So you're switching ballerina A, ballerina B, ballerina C, right? And if you go to this sprite section and you hover your mouse over any of the sprites, it will show you, it will switch between the different costumes so you can see. Some some sprites don't have any animation. Look at the bananas. If you hover there, it just stays there. So there's no costumes. There's no other costumes for the banana. But look at Avery. Avery does a little hand gesture. Here you can actually animate Avery to make her look like she's walking. Look at that. She's just switching between two costumes, and she will walk in the same place, but you can create the illusion of movement if you switch her two costumes and then also move her forward a few number of steps to make her move. So all of these, look at these, they all have some kind of animation. Some of them don't. I think, see the basketball, nothing. The bat, you can make the bat look like it's flying. You can see it's got about 3 costumes there. It's got 3 different positions. So you can experience, oh, the ball has changing colors. So you can see how you can change the costumes. And there's look at the number of look at this guy, he's a centaur. Oh, look at him, he does the thing. So all of these things have well, not all, like I said, a lot of them have animation, and you can really go to town with experimenting and just changing the costumes. That's the start of one of the things you could do. Now, I know you got projects that they are in terms of the competition. And so I think with the animation combined with what I taught you earlier this week, you might be able to come up with some very, very interesting projects. Of course, it's going to take a lot of experimenting. Now, with the last bit of time that I got left, and I went to the wrong place, I need to click back. I want to take us to a new program that we want to, no, I don't want to go there. Okay, I want to start a program with a sprite that we, check that out, which we were using yesterday. Or let's just pick any sprite. Okay, let's use the arrow. Okay, we're going to use this arrow to draw again, like what we did, right? But this time we're going to draw a shape, right? But this time we're going to ask the user what size shape he wants. We drew no asking about the competition. Yes, towards the end, towards the last 5 minutes, I'll explain about the competition again. Okay, now here we're going to do something pretty cool. We're going to get the arrow to draw a shape. Like, remember yesterday we were drawing shapes with the pen. Also, I got to get the pen. Watch how I get the pen. Click there and click on the pen, and it brings us the pen code. Right, so let's clear everything. So we have nothing to begin with. And then let's go to the sensing, and we'll say ask. And this time we will say, oops, sorry. Let's stop program. Okay. How, oh, what am I doing? Right. How many sides must I draw? Right. And of course, we're going to need the answer. Yesterday, we had a variable, and our variable was called, let's make a variable called sides, for how many sides the triangle had, right? And then we will say set sides to answer. Now you can see the pattern. Look at the previous code that we had, and you can see how this ask and wait works together with the answer. Now we've also got 2 other things on the screen, 2 other variables from the dragon, which we don't want anybody to see. So what we're going to do there is we'll just hide them before we start. We will hide variable fire. That's good there. See, when I run the program, what's going to happen? That variable's gone. And let's also hide the other variable, speed. Okay. And when we run the program, speed doesn't appear on screen anymore. Okay, now we're going to set sides to whatever the user answers. Can you see the computer is now? Let's run it. How many sides must I draw? It's kind of funny. An arrow is asking you a question. And then, of course, we will give the answer there. Let's say 3, and the user is going to press the tick. The arrow doesn't do anything because there isn't any code after that, right? So now we're going to draw our shape. We're going to go back to how we drew the shape. We remember how we did that? We said pen down, right? And then we went to motion, and we said move. Let's not make very big shapes. Let's stick with 50. Move. And then we said move 50 steps. And then we had to turn to the left. But our turn was calculated using the 360-degree thing with the division. Remember this from yesterday, right? So this was the operator that we used to do division. And what we said was that the turn is 360 degrees divided by how many sides our shape has. So now the user is choosing how many sides the shape has this time. And so we can't put 3 or 4 there because we don't know what shape is being drawn. So that is where our variable becomes so useful. We say 350 degrees divided by the sides. And so now it's going to turn, and I put 350, that should have been 360. 360 divided by the number of sides. And then, of course, we needed to put a little delay there so we can see it drawing. 1 second was a little too slow, and let's make that 0.5. And that now is drawing a side. Then, if you remember, we had a repeat loop that keeps repeating this drawing. We don't need the drawing, don't have to keep putting the pen down. So the pen down doesn't have to be inside the repeat structure. The repeat is just move 50 steps and turn according to how many sides you gave us. And that, oops, grabbing the wrong thing, will give you a shape. Now let's run it and let's see what it does. How many sides must I draw? Let's say we say 3, and the arrow goes, and look at that. It's drawing 3. But our repeat loop is 10, so it's going to actually run 10 times around there when we only wanted to go as many times as we have sides. So this repeat loop must only go 3 times because we only wanted to draw a 3-sided shape. So the repeat loop is also controlled by the variable called sides. Now watch what happens. Right. How many sides must I draw? Answer, the user will answer, and it will get stored in a variable called sides. So sides is a variable that tells us how many sides is the shape. Then we put the pen down and we say, right, now we're going to repeat so many sides. Because the user said how many sides and it's stored in sides, if he said 3, then this will be 3, and this repeat loop will go 3 times, and of course, you will get a triangle. And here we are dividing by sides there. So again, the angle is controlled. That's why we had to find a relationship between the angle and the number of sides earlier. Now let's run the program. How many sides must I draw? Let's say 3. And that's your triangle drawn. Let's run the program again and ask the question, how many sides must I draw? This time, let's tell him 4. And of course, you now have a square. Of course, because the arrow is starting from this direction where it ended off, your square is sort of tilted. So we can fix that problem, of course, by always setting the direction of the sprite, which we talked about earlier, to be in the 90 degrees. So we can always make him start point at 90 degrees, right? So how many sides must I draw? And now if we say 4, is always going to start in that direction. So that's a lot more neat and tidy. And now, isn't this cool? Look who's deciding on the shapes. The user will feel pretty cool. Let's maximize the program and let's run it and let's try different. Let's try 6. 6, click tick. 3, 4, 5, 6. And look at that. Now you've got a really cool program. The user is going to be pretty cool, especially if he's a young child just learning about shapes. The program can draw any shape as many sides as the user chooses. We've got the arrow pretty high up as well. Maybe if we take it, since we starting pretty low down, let's start him off there, and let's press the play button again. and let's maximize. Oh, I went, oh, okay, that's not so far. Because I want to draw like something really big. Let's try like 15 sides. Have you ever seen a 15-sided figure? Okay, that's not going to be good. Let's stop that. I went too far to this side of the thing. We most certainly are going to need our arrow to be at the bottom, maybe more towards the middle. I think that's kind of better. How's there? There looks good. Okay, I know I'm out of time, but let's just test run this one. Let's try 12. 12, tick, and let's watch it go. 6, 7, 8, 9, 10, 11, 12. That's a 12-sided closed figure. You just get these, hexagonally looking things, the more sides that they have, because the entire figure has to be completely closed. And that, of course, is now you giving the user full control of how your code, what he wants to do. Even here, we can use some of the what we learned in the Dragon program to even control the speed. Can you see we're saying wait 0.5 seconds? And if you want, you can even ask the user, how fast would you like me to draw? And you can control that situation there as well. So guys, that's what I wanted to teach you today. You can see you learned quite a bit. You learned how you're going to do input, where you're going to ask the user. Check it out. It's the ask and wait, and then together with the answer. And of course, this code will be part of the recording. So once you go onto the website, you can download this recording, and of course, you will have this code with you at all times. And then you can learn from it again, especially if you felt that was too fast in this hour. And you've got to experiment, kids. If this is your area, you'll find that we have so much of fun, just writing code. My daughter is also in grade 7. And, ever since this program started, like she spends sometimes a whole day just like I have to get her. She doesn't do any of her chores because she's stuck in front of the computer writing code. With the last 2 minutes that I have left, I just want to help answer a question that Noor Mohammed asked about the competition. So here's the detail. Can you see this? Oops, I dropped my mouse. Right. If you look at the code on screen, this is what you are seeing now is what we call code. What you are seeing here is a sprite that actually represents a robot. And you are now actually giving the sprite instructions, and it is following those instructions. So in actual fact, you are only in grade 7, but you are already learning how to give instructions to a robot. And what we want you to do is to write some code like this and hand it in as a project. So that's the idea. It's called the Afronovate project. You send your project by uploading it to the site. That's more or less what happens once you download it. But in fact, I'll try and get some details for you for tomorrow's class. Tomorrow, maybe if I'll spend 5 minutes showing you how to actually upload your project onto the site. But for now, work on it. Work on what you're going to be writing up. I gave you quite a few things that you could work with, but remember, you're not restricted to what I taught you. There's tons of instructions in the blocks that I didn't even use. And we've only had 4 days. So feel free to experiment and come up with anything that you like. But that's more or less that there's no real, it doesn't have to, we are not being restrictive of how big it should be. It doesn't mean it must be 10 lines or 20 lines. You're not restricted with sprites. You can use 1 sprite if you want. You can use 2 or 3. And remember, you're going to be judged only in your own grade. So you're only going to be judged among the other registered grade 7 participants. Now, there might have been only 10 or 11 in the chat room with us, but the others that are not here might also choose to submit projects. They have the option to do so since they registered with the program. But I think you have the edge, the advantage, having also participated with us. And you've learned a few things. Remember also, whether you win the competition or not, you will receive from Africa Teen Geeks with their logos a certificate of participation for having joined in the program. To receive that certificate, however, you had to have been logged in the sessions with me throughout this week. So that's what we're looking at with the competitions, and yeah, that's it. But thank you for your questions, and I will have a lot more information as we close up for tomorrow before we close as to how you will submit your project. But for the moment, write it up, and have it saved. I'll tell you how to upload it tomorrow. I'm out of time. Again, thank you for logging in. I hope you've enjoyed yourself with the animated stuff that we were doing today. Have a good day, guys, and I will catch you 12 o'clock tomorrow. Goodbye, everybody. Okay. I think the host